Um, in this section, I've got two different lecture videos, and you definitely will want to watch them in addition to what I'm going to show you today on Zoom, because they'll give you a lot more examples of the different types of equations. And I also have the steps written out on those, in those lecture videos, and in the little note files that are above each one of those, so you guys can download those and use them. That way you're not having to write down absolutely everything that's in the video when you take notes on the video. So my plan for today in Zoom is to just kind of go over one of each different type of equation that you're going to see in the homework assignment. We'll actually do 5, even though technically there's only 4 different ones. But when we do the second type of exponential equation, there's enough difference in how we handle like the base E equations and the other bases that I want to show you one of each. So we'll do 3 different exponential equations, and then we'll do 2 logarithmic equations from that part of the assignment. And I'll kind of go through the assignment, and because some of the questions ask for the answer in slightly different ways, as is the case for a lot of the homework assignments that y'all have. So I just want to be sure that you understand what it's asking you to give it. Okay. So do you have any questions on anything that we've done up to this point before we get started on the equations today? All right, let's get going then. The first few questions that you have, and it's 3, the first 3 that you have on here are exponential equations that can be solved by using the 1-to-1 property for exponentials. And that property says that if you've got an equation where the 2 sides of the equation have the same base, then the 2 exponents have got to be equal in order for that to be a true statement, that equation to be a true statement. So if we can get both sides of the equation in a form where the base is the same on both sides, then we can use this property to solve, okay? So I have chosen the one here. I was playing with my Bitmojis earlier. I've chosen the one here trying to find the right one here. Here we go. Found it. I can't see the whole thing when I look at it like that, so it's kind of hard for me to tell which one I'm looking at. Anyway, I chose the one that has one side that's got a fraction for the base, okay? And I'm actually going to show you 2 different ways you could work this problem. Not every single exponential can be worked by using the one-to-one property, because for some equations it would be very difficult to take both sides of the equation and find a base, one single number that we could use on both sides to write an equivalent statement for both sides. So problems 1 through 3, these all have numbers on each side of the equation where it's easier to find that common base and easier to write the exponents that you would need. So the first way we're going to do this is we are going to use that 1/2 that's already the base on one side as our common base. So what we'll do is try to figure out what we could raise 1/2 to make it 64, okay? And we'll do this in a couple of different steps. First, I'm just going to rewrite it, and then we'll start working on it. All right, so the first thing that we want to do, the fraction part of this, turning the 64 into a fraction, we'll do that with a negative in the exponent. And I'm actually going to do that last, okay, getting it flipped where we've got the reciprocal. The first thing I want us to do is figure out how to write 64 as 2 raised to a power. Okay, and we can do that with a calculator. Now, the reason why I'm picking 2 is because 2 is the denominator of the fraction base I want. And I know if I can get it to 2, I can just throw a negative on the exponent and make it flip. Okay, so what we will do, if I can get my little calculator to pull in here to the side, there we go. Come on. we will raise, always got an add, we'll raise 2 to several different powers until we can finally figure out what power would give us the 64, okay? So I know it's not squared because 2 squared is 4. It's not going to be cubed. 2 cubed is 8. So 2 to the 4th is probably not going to be it either because it's probably going to be still too small. 2 to the 4th is 16, so that's not it. 2 raised to the 5th power is 32, so that's not it, but we're getting closer. 2 raised to the 6th power is 64. So there's what I need. I'm going to go ahead and rewrite 64 as 2 to the 6th. So I'm getting closer. I don't have the 1/2 yet, but I'm closer than I was because my base is now 2. Now, if I want to rewrite 2 as 1/2, what I need to do is take the reciprocal and put a negative in the exponent. So I could rewrite 2 as 1/2 to the -1 power. And then of course that's still raised to the 6th, okay? You could do the same thing by just putting the negative on the 6. That's how we'll wind up here in just this next step anyway. Because what I have to do in this step is simplify the right-hand side. And to simplify something raised to a 2nd power, we multiply the powers together. So we're going to have 1/2 raised to the -6. Then we apply the 1-to-1 property at this point, because finally I have my 2 bases the same. So what we do, it feels kind of like you're canceling the denominator, but what you're actually, not denominator, the base, but what you're actually doing is creating a whole new equation. We're just going to set our 2 exponents equal to each other. And then if we needed to, from there, we could solve for x, but we're not going to have to do anything else because x is already by itself. All right, so the answer is going to be -6. And you probably could skip some steps going through that. For sure, right here, you could skip this one and just go straight from 2 to the 6th to 1/2 to the -6. Because if you want to rewrite something as a fraction, as a reciprocal, you can always throw that negative into the exponent and that will force that to happen. Now, the alternative to this, in most problems like this, there's one base that you could use as a common base, but there's probably some others as well, okay? And most of the time, if your base is not already a fraction, you probably can get away with just using whatever base you already have, okay? So like if we had 3 to the x equals 243, then I can use 3 as my common base. But here, if you look at 1/2 and 64 both of those would have a common base of 2. To get 1/2, we would just need 2 to the -1, okay? And then to get to 64, we got to have 2 to the 6th. We've already figured that out. So we could do it by using 2 as our common base also. And you can decide for yourself which one of these you think is easier. In all honesty, the 2 is probably easier. 1/2 is the same thing as 2 to the -1. And then 64 is the same thing as 2 to the 6th. So right now we already have common base. I just need to simplify my exponent on the left-hand side. So I'll multiply those exponents. Then we can use the 1-to-1 property. We come to the 1-to-1 property a step early, okay, a step before we did on the last one. But we do have to work on that equation just a little bit. I don't have x by itself, so I need to divide both sides by the negative. And again, we come out with -6, okay? So you are going to get the same answer whether you use the more obvious base or if you use one that you know is a base for both sides of the equation, but is not one that's sitting there right then, okay? So you do have the option, and like I said, usually one is way easier to use than the other one, okay? It just so happened that in this case, really both of them are about the same level. They both took the same number of steps to get through them. So it's just according to which one you feel better about, okay? All right, do you have any questions about this problem? Your number 3 will have a fraction base 2. 1 and 2, they both have integer bases for everybody. So they'll be a little bit easier than this one to do. Now, the next type of exponential equation is one where you can't do what we just did easily, okay? The two sides of the equation, there's not an obvious common base, and if we were to choose a common base, it would be very difficult for us to figure out what the exponents would need to be to force a common base on both sides. So we have an alternative method for those. This method can actually be used on the other exponential equations as well if you want to use them, okay? Now, this is the one I was talking about where we really have the same type of equations, but if they're base E or base 10, we can use a different property than we can if we've got any other base 6, base whatever, okay? The reason why is when we work this type of problem, we're going to take the log of both sides. And we're going to do that because there are properties that we can use to get x down out of the exponent, but we need it to be a logarithm, okay? So we're going to make both sides logarithms. Well, if we've got base E or base 10, we have a special log that we can use for both of those. Natural log for exponential base E, and then common log if it's base 10. If it's any other base, we could force, you know, we could use log base 2 or log base 12 or whatever. But the problem would be if we needed an approximate solution, it would be very difficult to get that because most calculators will only do base 10 or base E, okay? So it's best to use one of those two logarithms when you're solving these problems. It won't matter which one you choose to use, natural log or common log, unless the base is E or 10. If it's E, you'll want to use natural log. I'm not saying you couldn't use common log, it would work, but it's easier if you'll use natural log so that the bases match. And if you've got base 10, you'll want to use common log there again because the bases will match, okay? So we're going to look at one with base E first. This is actually a topic that's tracked on the final. You know how we had that separate little quiz for the midterm? The final will have one too, okay? And this will be one of the things that's on that little separate quiz. So there are several of these in the homework. I'll show you how to work this one, and then you can use how we work this to figure out the others. Plus, there are several examples in the lecture video too, like this. So let's go, whoops, I didn't mean to twist that all around. Let me lock that down before I move it. All right, now the property that we are going to use is one of those basic properties from the second section of homework that we did, okay? I'm gonna write it specifically for natural log, but I'll show you the other forms as well. The form that we will use is natural log of E to some power is equal to whatever the power is, okay? We can do that because natural log is base E. So the base of the logarithm and the base of the argument have to be the same value for this to work, okay? If you were doing common log, it would look like this. And if you're doing any logarithm, this is the more general form here. I don't know what that was. I don't know if y'all heard that or not. It sounded like something hit a wall or the floor or fell over or something. Who knows? You never know around here what's going on. All right, so anyway, this is a property that we're going to use, okay? So we start with E raised to the 2x plus 1 is equal to 4. We want to isolate the exponential. Now, I don't have to do anything with this one because this exponential And what I mean by exponential is this term right here. It's the base and the exponent, those two pieces, okay? I don't have a coefficient to move. I don't have an extra term that needs to be moved. It's already isolated, so I don't have to do anything for that step, but that is the first step. The second step is to take the log of both sides. Now this is where you'll choose either natural or common log. Since it's base E, I will use natural log. And the step's very easy. All you have to do is write ln or log in front of your two sides of the equation, okay? Then we use that property. The whole point in taking the natural log of both sides is so that we can use the property, okay? So natural log of E to some power is equal to that power, period. So that means that natural log of E to the 2x plus 1 is just going to be 2x plus 1. Now, all this is going to seem really weird because you're not used to doing this type of an equation, okay? But you just have to follow the steps as they're given. Why do we take the natural log of both sides? Well, because we want this form. We want this particular property to work because we need to get x down out of the exponent, okay? And that's the way we do it. And so that's why we take the natural log of both sides. That's why we use the property. And then at this point, we just solve for x. So we need to subtract 1 from both sides. Now you can put it behind or in front of the natural log of 4. Doesn't matter. I like to put it in front because if I put it behind it, it kind of looks like it's supposed to be part of the argument, even though it's not. And then we need to divide by 2. Now, this is what's called the exact solution. The exact solution is what you get before you type it into a calculator, okay? The logarithms will still be in there. You won't have any approximate values. You will not have rounded anything, okay? Exact solution, there is no rounding in the exact solution. That's where the name comes from, exact, okay? Some of the problems ask for exact, some of them ask for a rounded answer, and then some of them, like this one, will take either, okay? There's one question, and I can't remember which part. Seems like it's early, before the ones that are base E in this part of the homework, that asked for both forms. So it's got 2 separate blanks, okay? So this is exact. Now, to get the approximate or rounded solution, what we have to do is throw that in a calculator. Now, this calculator that I'm using, when you do a logarithm, either common or natural log, either one, you have to type the argument in first and then hit the log. So what I'm going to do, I'm going to start with that, okay? I'm working on the numerator, so I'm going to do the natural log of 4, and then I'm going to subtract that 1 from it. Even though I've got it written in front of it, I can still do it this way if I want to. Then I'll just divide that by 2. And the problem asks for the decimal rounded to 4 decimal places. So 1931 is what I get for that. That's the approximate solution. And approximate here means rounded. Okay, we rounded it to 4 decimal places. So if we go back up here, it says in terms of logarithms, find the solution in terms of logarithms. That means the exact solution, or correct to 4 decimal places. That means the approximate. So you can type in either. It will be much easier to type in the approximate solution. So that's a good reason to find the approximate solution. I would be careful though. If you decide to do approximate solution and it tells you it's wrong, try typing in your exact solution first before you go back and change anything, okay? Because it is very possible that you just made a mistake typing it in the calculator, and all that's wrong is maybe maybe you typed in 3 instead of 4, or maybe you left a negative off or hit plus instead of minus. It could be anything. So check that. before you decide that you've done something wrong, okay? Because it may have just been a small careless error getting between the forms that caused it. Also check your rounding too, okay? The tolerance is probably pretty tight on these, and so if I typed in 0.1932 instead of 1, it would probably tell me it's wrong. So just, you know, double check that before you go, well, obviously I don't know how to do the problem. You may have done fine, okay? It may just be that rounding was a little off or you typed it in the calculator wrong. So check those things before you write the problem off, okay? Do you have any questions about working this one? It's definitely a new and different process. It's going to feel kind of weird because it's not like anything else you've ever done. All right, let's look at the one where it's not base E or base 10, okay? Because we use a different property for that. Let me find it. That's it right there. And when I picked this one, I picked the most complicated one, okay? And so this one's going to be harder at the end of the problem where I am trying to simplify what's left, okay? Some of your questions are just like your exponent is just an x instead of 5x plus 3, and those are going to be your easiest ones. The ones where you got a more complicated exponent can be a little tricky to simplify, okay? Now, this question is like several of them that you have in your homework where it doesn't really say how to answer. It doesn't say exact, it doesn't say approximate. But if you tap in the blank, at the bottom of the math pad, it'll say something about entering a, I forget what it says, enter a mathematical expression. And I have double checked this one. It will take the exact solution for sure. Okay. This one had such a big, crazy looking exact solution that I decided to type it in instead of trying to put it in a calculator, just because I thought it would be easier to deal with, and it was, and it took it. Okay, so I think exact is probably going to be the way you want to go unless it says something about approximating or giving a decimal rounded to 3 or 4 decimal places, okay? All right, so when we do this problem, we're going to need this property. This is that power property from the last section. Log base b of m to the p power is equal to p times log base b of m. So it's not as nice as the last property where we could just totally get rid of the log. Here we can't get rid of the log, but it does allow us to get x down, okay? So again, the first step would be to isolate. I don't have anything to move on this one, so I don't have to move anything. And then after that, we do the log. And you can use common or natural log on this one. It won't make any difference because the base is 6. I almost always use natural log just because that's what I do, okay? It doesn't matter. The only time I use common log is if it's base 10. So natural log of 6 to the 5x plus 3 is equal to the natural log of 1296. So we use our property. I'll pull down my exponent, 5x plus 3. You do need parentheses around that because it's a binomial. Times natural log of 6 is equal to the natural log of 1296. Now you have the option here. We need to solve for x. So you could distribute the natural log of 6 if you wanted to. I'm not going to. I'm going to divide both sides by the natural log of 6 first and move it. Because what I want to try to do is move everything away from x. So I'll divide both sides by natural log 6. And that gives me 5x plus 3 equals natural log of 1296 over the natural log of 6. Then we need to subtract 3 from both sides. So we have our fraction here. And remember, that's really just a number, okay? I know it looks crazy because it's got letters and numbers and natural log and whatever all there together. But if you were to type that in your calculator, it would spit a number out at you, okay? So that's just a number. And we're going to subtract 3 from that number. And then in our last step, we're going to divide everything by 5. And I'm going to do that term by term to make it a little bit easier to simplify, because right now that gives me a complex fraction right here. So we're going to have to deal with that. It's not a big deal, okay? But we do have to deal with it. So that's going to give me 5 is equal to, complex fractions are pretty easy to clear. If you've got one that's this simple where it's just the numerator is term over term, denominator is term over term. Very simple. No addition and subtraction tied up in there anywhere. So all I have to do is multiply the numerator fraction by the reciprocal of the denominator fraction, which would be 1/5. Okay? So x is equal to 1 times the natural log of 1296 over 5 times the natural log of 6. So I'll pull that in front. Okay, that takes care of this right here. And then I've just got minus 3/5 left. And I just typed that in straight, just like that. And it took it. I never did get the approximate value for it. You can if you want to, but for that one, my calculator on the iPad is so funny about natural log. I would have to do it in pieces and write everything down and then do the operation. So I'm not going to do that. I'm just going to leave it as is. So up here, it would be natural log of 1296 divided by 5 times the natural log of 6 minus 3/5. And that does work for that one. All right, any questions about that one? Like I said, that one was harder once we got x down than it was to get x down. We didn't have to struggle with it too much as far as the first couple of steps. And then, you know, we just had to deal with algebraic simplification after that. So that's where most of the work goes into these. All right, so that brings us to our logarithmic equations. Now, the thing you need to remember about log equations is they do lie to you. They'll give you an answer that doesn't work occasionally. So we do have to check them, okay? It's not an optional step. It's a step we have to take at the end of the problem. It's pretty easy to check them because what we really want to be sure of is that all of the original arguments in the original equation have to be positive. So if we plug a number back in, we should get all positive arguments. If any of them are 0 or negative, then that number just won't work, okay? And it is possible to get a logarithmic equation that has no solution. If you run into that on the homework, probably DNE does not exist is what you need to enter for that, okay? Let's look at a couple. Here's our first type. And for this one, every single term is a natural or is a log, okay? So if every term is a logarithm, use the one-to-one property. Logarithms have a one-to-one property just like exponentials do. It's a little different, okay? And so that property for a logarithm, let me move this down just a little bit. Looks like this. If you have log base b of an argument set equal to log base b of another argument, that can only be true if the two arguments are equal. We won't have to do any changing of bases, okay? Like we did with the exponentials. The bases will already be the same, okay? And so all we'll have to do is recognize that, make sure there's one log on each side, and then set the two arguments equal. If there's more than one log on each side, we will have to condense like we did in the previous section. We'll have to do that condensing with the properties. This one doesn't have that. This one's just got one log on each side. So we're in perfect form for this question, but I will do one for the next example where we do need to condense it, just so you can see that. All right, so let me rewrite this. And we do have that one-to-one form. I do have natural log of m equals natural log of n. And so I'm going to set m equal to n, okay? So m would be this x plus 4, and n would be 6x. Then we solve. So we need to subtract x from both sides, and then see what we'll get. So 4 is equal to 5x if we subtract x. Then we need to divide both sides by 5. So x is equal to a positive 4/5. Now, as I said, you do have to check these. Check to make sure the arguments are positive. Now, it doesn't really matter what number we get. We just want to make sure they're positives, okay? So you can check them with the calculator if you have a weird fraction, or you don't even have to go so far as to check them that close. You just need to make sure they're going to give you a positive number. So if we look back at the original problem, we do have a positive x value. And so you can kind of tell by looking at it that we're going to be okay, because if we plug a positive x in and then add 4 to that, that's still positive. Or if we multiply 6 times a positive number, that's going to be positive too. So it's going to work out correctly. I'll go ahead and plug it in so you can kind of see what you can do if you do need to investigate it a little bit farther. 4/5 plus 4, we can pull the calculator up to do this. 4 divided by 5 plus 4 is 4.8, so that is positive. And then I've got 6 times 4/5 over here, and that's going to be 24/5. I don't have to get the calculator for that. That's also positive, and so they check. Our answer is going to be 4/5 for x. Do you have any questions about that one? They're cleaning the floor in the hallway if you hear that rumbling. I'm going to give it a minute to pass. Go ahead and pull this one up while I'm waiting on the hall thingy to get out of the hallway. Okay, so for this one, if, how do I want to put this? If there is a non-log term, convert to exponential form. That's how we're going to solve this one. By doing that conversion like we did in the it wasn't the first section, it was the second section that we did in this unit. Okay, just do our conversion. So just like the other one, you first have to have a single logarithm on one side and your constant term on the other side. So we do need a single logarithm. And right now I have 2 logarithms, so I need to condense those, okay? So this, if I look at it, I don't have any coefficients, so I won't need power rule. It's not addition. I've got 1 positive log, 1 negative log. So if I push those together, that's going to give me a single logarithm with a numerator from the positive log, x plus 3, and a denominator from the negative one, x plus 1. I'll put those two together. Then we got to convert it. Okay, so I need to know what my base is, because when we convert to exponential form, we write the base first. So I don't have a subscript. I have to assume that my base is 10. It's common log, so my base is going to be 10. The hallway cleaner again. So you write your base down, and then you swap the other two things around, okay? So what the logarithm is equal to is my exponent. So I'm going to bring it in close to 10 as the exponent. And then my argument will be on the other side of the equal sign. Then we'll go ahead. We want to solve this for x. Okay, I lost my one student who was still on here with me, so I'm going to go ahead and finish the problem. If he pops back in, I'll update him on where I've gotten to. All right, so this is a rational equation, okay? It's going to be an easy one to work, though. We did rational equations way back in August. It's been a long time. It's like one of the first couple of sections we worked on. But this is only going to have two terms. So if a rational equation only has two terms, you can treat it like a proportion and cross multiply to get your answer. Pretty easy to do. All right, so we first need to go ahead and square 10. And I'm going to write that as a fraction, because for me it's easier to see the cross multiplication if I've got a numerator and denominator on both sides. So then we cross multiply 100 times the x plus 1 and 1 times x plus 3. Then we distribute 100x plus 100. And then 1 times x plus 3. So 1 times 1 times x, sorry, 1 times 3. Get your x's together and constants together. So we subtract x from both sides, get 99x. Subtract 100 from both sides, get negative 97. So x is negative 97 over 99. And then just like the others, we do have to check. Okay, so go back to the original. Don't use the one after you've condensed, use the original, okay? I guess you could use the one after you condensed, but I think it'd be easier to do it this way anyway. So we're just checking the arguments. Negative 97, sorry, I wrote that wrong. Divided by 99. Now that's not quite negative 1, okay? So if you're just kind of looking at it and trying to decide if that's right or not, then if it's, you know, negative 0.9, we'll say, it's going to be 0.9 something, but negative 0.9, we could tell that's not going to be negative. That is going to be positive, okay? You can check it with your calculator if you want to. And then for this one, same thing's going to happen. If this is negative 0.9 plus 1, that's still going to be positive. Okay, and negative 97 over 99 is, we'll just see what it is. 97 divided by 99. So it would be negative 0.98 if we rounded it. Okay, so that's still a little bit smaller than 1. So when we add it to 1, we're going to have a positive number, although it will be kind of a small positive number. So they're both positive. That means we get to keep it. And negative 97 over 99 is our answer. And that is the last one that I was going to talk about today, okay? So be sure, if you have not already watched the lecture video, do that, okay? There's plenty more examples there. The steps are written down in the video. You definitely want to watch that to just be sure that you know what you're doing as you're going through this section. Don't give up on me now. We're almost done, okay? We've got one more section to cover. That's solving systems of equations. We'll do that next week on, see, y'all are Tuesday, Thursday, so we'll do it on Tuesday. And then Thursday of next week will just be a day when y'all can ask me questions, okay? The following week is exam week, and I am going to be sending out an email soon, probably tomorrow at this point in the day, about how we're going to do exams. I am planning on opening them. They have a password right now because they're not ready yet. I haven't finished working on them yet because I'm trying to get them just exactly like I want them before I release them to you. So I'll take the password off probably towards the end of the week next week. It'll be off at least by Friday so that those of, well, you guys will take it. I can't remember if y'all's is on Tuesday or Thursday, and I don't have a copy of it sitting here in front of me, so I'm not sure what your official final exam day is, but the plan is that it be open for a couple of days before that because you can't take it late. It's got to be done that day, okay? All of any old homework or anything like that that's got to be made up, you've got to have that done that day because the course will close down after that day, and I have to get grades in within 24 hours of that. And I'll work on them the next day because that's what I usually do. So, everything's got to be done by the day and time that the final's supposed to be done. So that'll be the end of it. There won't be any lateness after that, okay? Can't do anything after that. All right, so anyway, I'll get y'all an email sent out about that. And then we'll have Zoom on Tuesday, and then I'll have an open Zoom on Thursday where you can come ask questions, okay? I will see you guys later.